Okay, good afternoon, all of you. Yesterday, we have started our lectures on this non-conventional machining subject. Okay, and we have discussed the syllabus and the content of each and every unit. And we were talking about the how these non-conventional processes are classified from the manufacturing processes. Okay, so quickly I will recap on that point also. Okay, as we know that our manufacturing processes are can be divided into two types. Okay, one is the primary manufacturing process and second is the secondary manufacturing process. Okay, in primary manufacturing process means what? These processes provide the basic shape and size to your workpiece or the material as per the your requirement or the as per the drawing or as per the designer's requirement. Now, which are that primary manufacturing processes? So, in that category, you can take example of casting, forming, then your powder metallurgy. So, like that processes you can include under the primary manufacturing process. Now, second group or category of manufacturing process is the secondary manufacturing processes. Okay, now these are the processes, okay, which provide the final shape and size with tighter control on the dimension. That means you will get the final accuracy or final shape with the tighter control on the your dimension, accurate dimension. Okay, as well as the whatever the surface characteristic is there, so that will be the up to the mark. Okay, so that is the second category, secondary manufacturing process. Now, in that category, we have material removal processes. Okay, in that category, we have material removal processes under this secondary manufacturing. Now, again, that material removal processes, again, it is divided into the mainly two groups. Okay, in that first group is conventional machining process. Okay, first is the conventional machining processes. Now, what is that conventional machining processes? So, these processes are mostly remove the material from the your workpiece in the form of chips. Now, how that workpiece will be removed from the your workpiece? Okay, in the form of chips. So, to remove the material in the form of chips, we need to apply the force on your workpiece material. Okay, now how you are going to apply the force on that your workpiece? So for that purpose you need or we need cutting tool, okay, having the edged shape. Again, in that we have one basic condition that whatever the hardness is there or whatever your cutting tool is there, no, so that should be harder than the your workpiece. Okay, if you take the hardness property, then for traditional machining process or we can call conventional machining process, so for that the hardness of your cutting tool should be harder, should be more than your workpiece, or in another word I can say cutting tool should be harder than the your workpiece. Okay, so for conventional machining process, basic two requirements are there. One is the cutting tool should be harder than your workpiece, and second is the physical contact should be there between your tool and your workpiece. Then and then only you can apply the force onto the your work material or workpiece. Okay, by using the your cutting tool. Okay, and by applying the cutting force or that by cutting force, you can remove the material in the form of chips. Okay, so this is first category under material removal rate. Now, which are the conventional machining processes? So we know that processing is not your turning is there, facing is there, or boring, milling, shaping, slotting, grinding. So all these, whatever the we are calling traditional processes are there, so that are conventional machining process. Now let us take the another side of the this machining process, that is called non-traditional machining processes or non-traditional manufacturing process, or we can call non-conventional machining process. Okay. Now what is this category? So it is defined as a group of processes that remove the excess material. Okay, that remove the excess material by various techniques. Okay, again these processes are used to remove the material. Okay, excess material or you can whatever you want, no, that material you can remove from your workpiece. But how that removal will happen? So by using the various techniques which are involving the different forms of energy. Now, which are the different forms of energy? We saw your mechanical energy, thermal energy, electrical energy, or chemical energy, or combination of these energies. Okay, you can take separate mechanical energy to remove the material, or you can combine that mechanical energy with electrical energy or with thermal energy. Okay, so that combination of this energy you can use for what purpose? To remove the material from whom? From your workpiece. Okay, but here also one condition is that here we do not require sharp cutting tool. Okay, here we do not require sharp cutting tool. Okay, as it is needed to be used for the your traditional or conventional machining process. Okay, here your physical tool is not required. And another point about the non-conventional machining is that here no physical contact between your tool and your workpiece. Okay, there is always small gap between your tool. Okay, now sharp cutting tool is not required. Okay, but if you see when we will learn EDM. Okay, there we are calling one part as a tool. Okay, electrode. Okay, for that electrode we are calling tool. Okay, so cutting tool, sharp cutting tool is different. Okay, and electrode is different. Okay, in non-conventional machining process, for electrode we are going to call tool. Okay, not as like our for at lathe we are using the old cutting tool. Okay, so not like that tool is required for this non-conventional or non-traditional machining processes. And during this non-conventional machining processes operation, there should be there is a requirement of small gap, or we can call there is no physical contact between your tool and your workpiece. Okay, there is always small gap. It is called inter electrode gap. Okay, IEG. Okay, when we will move for in chapter number 2 or 3, then you will get to that point. IEG means what on. Okay, so this is a category non-traditional machining processes. Okay, now just here I will highlight the some examples of this non-traditional machining process. So in that example, yes, we have seen the syllabus. In that syllabus, I have given the abrasive jet machining, AJM, water jet machining, WJM, okay, EDM, electrode discharge machining or electric discharge machining, wire cut EDM, then electrochemical machining, ECM. Okay, another that electrochemical grinding, ECG is there. Then photochemical machining, PCM. Okay, then laser beam machining, LBM, electro electron beam machining, EBM. So like that we have the non-traditional or non-conventional or another we can call advanced machining processes. Okay, so this is the background of our point. Now we are at one basic question that why do we need the advanced machining processes? Okay, so this question we can take in another way that why we are learning this subject. Okay, what is the importance of this subject in industry? Okay, so the answer I'm going to tell now. Okay, whether my voice is audible at your end. Okay, please say yes or no. Some student can say whether my voice is audible properly. Okay, Dasharath, whether my voice is audible at your end. Okay, so let us move for that point. Okay, why do we need advanced machining processes? Okay, as I have mentioned that non-conventional machining processes or non-traditional machining processes or advanced machining process all are equal. Okay, so the first and foremost question arises that why do we need advanced machining processes? Okay, when there are already so many types of our traditional or we can call conventional machining processes uh, are there. Okay, and that we know that. Okay, we already know that. Okay, so again I will take here example. For example, our turning, milling, grinding, shaping, and so on. Okay, so these are the traditional machining processes. Okay, so we all know that these days, okay, a lot of research is going on the field of our engineering material. Okay, yesterday only I have given the reference of our manufacturing technology or manufacturing processes or You can take the example of metallurgy. So in that field, okay, field of we can call engineering materials. Okay, in that field, lot of research is going on. Okay, and if we take or if you want to classify the engineering material, okay, now we are considering the metallurgy part first. So if we if we want to classify these materials, no, in the slide I have shown, then you can classify our engineering material into three categories. You can see, say first category is that metals and alloys. Okay, then plastics and composites. This is second category of engineering material, and third is the ceramics. Okay, so these are the three categories of your engineering material. Now these days material, especially if you take plastic or composite and the ceramic, so these are the more popular, okay, amongst the in all industry, okay, or among the customer or user, okay, than that of the metal and alloy. Okay, so your plastic, composite and ceramics, so these materials are more popular in the industry as compared to this your metals and alloys. Okay, nowadays I'm saying nowadays. Okay, so definitely I can say these new materials have some advantages, okay, over the other materials. New materials means what? This your plastic, composite and ceramic. Due to that only, in industry many researchers are doing the research in the engineering material field. Okay, they are going for optimization, and by changing some their property, they are uh, going for resulting some optimization also. Okay, so these new materials have some advantages over your other metals, which are the commonly used. If you take, or especially you can take example of this metals and alloys. Okay. Now, another question is that how to machine these metals. Okay. Now we got the answer that in industry nowadays we are using this plastic, composite, ceramic, okay, than this your metal. But another question is arises is that how to machine these metals. Okay, common question is there. So now how this question arises, because if you see that ceramics, normally we can use ceramic tools for cutting the metals. Okay, ceramic tools are used for the cutting the metals, and uh, as well as for alloys, to cut the alloys we can use our ceramic tool, or we can consider another material. So now when workpiece material itself is the made up of the hard material. Okay, for example I'm taking, if your workpiece material is itself made up of the your hard materials. Now which are the hard materials? Like your ceramics. Okay, if your workpiece material is itself is made up of the ceramic material. Okay, ceramic means here I am taking example. Then another question arises is that which material will you use for the cutting the ceramics? Okay, which material will you use for the cutting the ceramic? Correct, because we know that hardness of the ceramic is very high. Correct. And if you think about the traditional machining or conventional machining processes, then it is very difficult to cut that ceramic material, okay, which is harder than your tool. Okay. So if your workpiece is harder than the tool material, then how to machine it? That question is arises. Okay, so this was the one of the reason that researcher in the field of this manufacturing, that in the field of manufacturing, the researcher has started thinking for the research purpose. Okay, I will repeat: if your workpiece material is harder than your tool material, then how to machine that workpiece material? That question will arise. Okay, so due to that, or this may be the one of the reasons that the researchers in the field of manufacturing started thinking to evolve new type of machining process. Okay, in the researchers in the field of manufacturing processes, or that machining process started thinking, they have started thinking what to do, how to do the machining, or how to cut the that hard material. Okay, so they have started for us to evolve the new type of machining process, so that we can cut that hard material. Okay, which is difficult to cut using the traditional or the conventional machining process. Okay, so now in they are searching for the manufacturing process where there is no barrier about the your workpiece hardness. Okay, workpiece about the workpiece hardness, there should not be any barrier, or there should not be any problem. So to on uh, to find the solution on that problem, they have started thinking, and they have started to evolve the problem. And after thinking and after evolving, they got the solution. They found the solution, and the solution is that advanced machining processes. Okay, advanced machining process. So this solution is they found. Okay, got it. So this is the one reason for what purpose we are using, or how to machine them that hard material. So the answer is that, or solution is that, advanced machining processes. Okay, getting it. So we will move for further. Now the question, another question arises, that what are the present day demand trends in various kinds of industries, especially if you take the industry like aerospace, missiles, or automobiles, or nuclear reactors, etc. So in this sector of industry, uh, what is the present day demand trend in this industry? So that question also arises. Okay, so the whatever the engineering materials are there, okay, which are in demand in the present time or present day, they should have have a much superior properties. Okay, they should have some superior properties that are available, like ultra high strength, then hardness, then very high temperature resistance. Okay, so these are the superior properties of engineering material. And nowadays or present day, the demand trend is that we are maximum using this engineering material having the much superior properties. Okay, I repeat that. Which are the superior properties? You can consider metal should have the ultra high strength, very high hardness, very high temperature resistance, because such properties are essential, or that are requirements of certain components. Okay, now which are the components in this mentioned industry? So just like your turbine blade, okay, you can consider the turbine blade, where we need very high temperature resistance, then uh, ultra high strength also. Okay, so in case of turbine blade, we should have the this properties, because if you take the uh, example of this turbine blade, so turbine blades, because they operate at 1100 or 1200 degree centigrade, so we should have the, or that metal should have the superior property, very high temperature resistance. Okay, so at this high temperature, that means near about 1200 degree centigrade, so at that high temperature, this component, or that your turbine blade should sustain up to that proper up to that temperature. Okay, so that is important, or I can say that that should be able to retain their shape. Okay, because if temperature increases for some material, due to temperature their shape may change. Okay, so that material, that superior in their material having the superior properties, that should retain to their original side shape and the other properties. Okay, that means metallurgy properties should be retained at that high temperature. Okay, whenever that component is in use. Okay, so again in that, again when ultra high or strong metals are used no as a workpiece material. Then another question arises is that how to machine such material, because ultra high strength material means having the high hardness also. Okay, so the question arises is that how to machine such a machine, such a workpiece or a metal. Okay, here I am giving the some case studies or the actual situations. Okay, some problems, and the solution will be the our advanced machine process. So, this is third case. Okay, if you take the ultra high strength material, okay, which are used as a workpiece material, then question arises is that how to machine such material. Okay, so that situation will be difficult to machine that ultra high strength material. So it becomes very difficult to machine them by our traditional or conventional machining methods, because the basic principle of our traditional machining or our conventional methods is that your tool metal should be, or you can consider hardness of your tool material should be much higher than your workpiece material hardness. Okay, that we know that, or already I have told also that. Okay, so as a result of this, researchers again thought about that also, that problem, and researchers over gone for over a period of time, and they have evolved with the new technology where there is no barrier about your workpiece hardness, okay, or your that property of high strength. Okay, and the solution or that they have evolved a new process that is known as advanced machining process or non-conventional machining process. Okay, so this is a second reason that why we do need advanced machining process, or why to learn this subject also. Okay, so this is second situation where you will get the justification about our question, that is why do we need a advanced machining processes. Okay, so while using this advanced machining processes, hardness does not remain as a barrier for machining any metal. Please remember this point. While using this non-conventional or advanced machining processes, there is no barrier about the hardness of your uh, any metal which will act as a your workpiece metal. Okay, now let us move further. Now, there are various limitations with our conventional or traditional machining processes or methods. For example, which are that limitation? So, for example, workpiece hardness. Okay, as we know that workpiece hardness should always be the lower than the your tool hardness. Correct. Your workpiece hardness should be lower than your tool hardness. And the present day industries, in many cases, in present day industries, in many cases, uh, they need very high level of surface finish. That means they want surface roughness value. If you take RA value, surface roughness value, it is indicated by the RA. Okay, surface roughness value, that is always in nanometer. Okay, that should be very low. That time also the problem arises how to do the operation using the traditional machining process. Okay, so some industries are in demand of nano level surface finish. Okay, let me accuracy, nano level surface finish. Okay, where the RA value for surface roughness value, which is in nanometer. So that array value should be in the range of 1 nanometer to 999 nanometer. So industry, they are searching, or they want that much surface roughness value. So there are various components, just like I have given the example of the our turbine blade, okay, which are in so the turbine blade, there are various components, okay, which are here I have mentioned that 3D parts. Okay, this is another example. 3D part means in nature. Okay, they are used in a machine. Okay, in the also system also. Okay, so the question again arises is that how uh, how to make such 3D component. Okay, how to make a 3D component component. So it is very difficult to make the 3D component by using our traditional or conventional machining methods, because many of these 3D components are very complex in nature. Okay, we know that if you see the 3D components, they are very intricate shaped components are there. So it is very difficult to machine that 3D component, or to produce that 3D component using our conventional machining process. Okay, so I was talking about that many of our these 3D components are complex in nature or integrated shaped uh, in nature. Okay, so they are sometimes they are made up of the super alloys also. Okay, which are very hard. Okay, super alloys having, we know that again it is very hard material. So some of these super alloys have the hardness as good as your more than that your cutting tool material also. Okay, if you take the example of our super alloys, no, sometimes the hardness of the your super alloys, it is more than the your tool material. Okay, so that time again that question will arises, how to do the machining operation. Okay, so due to the one side that complex geometry of 3D component, and another side is very high hardness, it is very difficult to machine them, that means to machine the super alloys using the or on the your conventional machining tools, and by also processes, it is very difficult. Hence, many industries use the CNC machine tools. Okay, CNC machine tool, we know that to obtain or to produce the 3D parts, we can use with the superior quality or the surface value also. Okay, so many industry gone for the CNC machine tool. Okay, to overcome the problem of your complex geometry of your 3D components. Okay, so that CNC machine tools that are as we know that the CNC are computer numerical control machine tools. So they have used that CNC machine. Now further, by increasing your for example workpiece hardness. Okay, by increasing workpiece hardness, it will leads toward the your decreasing economic cutting speed also. Okay, if you increase the workpiece hardness, then it will lead to the decrease in uh, economic cutting speed. Okay, that means your productivity will goes down. Okay, or you get lower productivity. That means more expensive component will be there, and more time also it will consume for your production. Okay, for example, if hard metal, if you want to face using the our traditional lathe machine. Okay, lathe machine is the a system. Okay, and in that we are using some sharp cutting tool. So that time what will happen, if your work is material is hard, then time will consume, and your productivity will go down. Okay, so again non-metals are there, and which are used as a workpiece metal. Okay, just like stainless steel, then high strength temperature resistance super alloys. Okay, so these types of non-metals are also used as a workpiece metal. Okay, so again question arises is that how you can machine, or how we can go for machining of these types of machine. Okay, like non-metallic workpiece. Okay, so now here as I have told that the question arises that how you can machine them, means what, how you can perform the operation, how you are going to remove the metal. Okay, here machine means that you can consider as a operation. Okay, don't think that machine means the machine system. Okay, so machine means what? Operation. It may be the turning, fixing, it may be the drilling. So the question arises that how you can do the machine on them. Okay, so further, when tool material hardness is very close to the your workpiece material hardness, no, then you require much superior quality of cutting tools. Okay, I repeat, when tool metal hardness is very close to your workpiece material hardness, then okay, using traditional I'm talking. So then you require much superior quality of cutting tool metal, and many times it is not feasible for you to get that superior quality cutting tool. So Again the problem arises, and the solution of this all problems, no, solution of this all problems is the your advanced machining processes. Okay, the solution of this situation or these problems also your advanced machining process, where using these advanced machining processes you can do the machining of high strength or non-metal metal or or there is no barrier of the hardness also. Okay, so no need to go for the superior quality of the tool materials. Okay, using advanced machining process you can do the machining operation. Okay, so this is third situation, from where you will get the answer is that answer of your question, that why would you need the advanced machining processes. Okay, so now apart from the workpiece metal properties, okay, apart from workpiece properties, there are product requirements also, okay, which are very complex in shape. Okay, product requirement in that they were very complex in shape. Sometimes you may require to machine a component in a inaccessible areas also. Okay, machining of a component in a inaccessible areas. So which is not possible, or I can say which may not be feasible for your conventional machine tool. Okay, say for example, if you have single point cutting tools or multi point cutting tool. Okay, so it is difficult to do the operation in inaccessible areas, okay, using this cutting tool. So there you definitely require our this advanced machining process or non-conventional machining process. Okay, so as I mentioned, there you require definitely this advanced machining process. For what purpose? To shape that component to get the perfect size or accurate size and shape of such components. Okay. Again, third product requirement will be the your tolerance. Okay, so tolerance requirement may be very small. In many cases, tolerance requirement is very small. Say, for example, 10 micron, up to 10 micron, you have to work on that workpiece. Okay, so depending upon the requirement of component, product requirements are also there. So you need better, again another requirement, maybe you need better surface integrity. Okay, so it is very important to understand that what surface integrity means. Okay, so the surface after machining should not have any defect, such as a micro cracks or poor surface finish or heat application. So it is called surface integrity. Okay, surface after machining should not have any defect such as micro cracks, poor surface finish, or heat affected zone. It is called surface integrity, and that in many cases we need better surface integrity. So such defects or the product, such defects or poor surface integrity should not be there. Otherwise, your component may get rejected during the inspection. Okay, so that is the product requirement in industry also. So we need to take care of these needs also. Okay, another need maybe the miniaturization of your products. Okay, so this is another aspect which forces us to use the advanced machining processes. Okay, so in the older days, if you take the example of older days or even today also, okay, we use the landline phones, okay, which are much bigger in size as compared to the mobile. Okay, so whatever these mobiles are there now, they have such much more capabilities than the your landline phones also. So you can internet with the help of this mobile. Okay, we can use the facility of the internet with the help of our mobile. We can send the email, and can do the some financial transaction also with the help of our mobile also. So everything is compacted in a very small size of the product, and that is we are calling as a mobile. So when if you take the another miniaturization example I have told, that landline to the your mobile. Okay, so again if you take example that very old computer, okay, say in 17s or the 80s era. So very old component computer are there, no? So they are of the room size, okay, that sometime that could not have memory more than what you have in our today's laptop. Okay, it is very small in size. Okay, now if you take example of today's laptop, okay, hard disk, having the capable of maybe 1 TB or 2 TB. Okay, and in older days for 1 GB also we need a more space and size also in the older computer. So from older that big computer to the our that small laptop, this is called the miniaturization, and this miniaturization requires a very small size of your component with, okay, no, just to not to go with the size, we need different capability also. Okay, we need different capability. So this is a called managed miniaturization, and this miniaturization is required very small size of your component along with different capability. And for machining these components, okay, miniaturized components, okay, or products, definitely you will require the process other than your traditional machining process. Now other than the traditional machining process, definitely you will go for advanced machining processes. So this is another reason that why to learn this subject, or why to go, or why to use, or why we need this advanced machining process. Okay, now industries always talk about, if you take the if you go in industry, then in industry you might be heard that they are talking about the high production rate. Okay, they need in the industry they need manufacturing process which can give high productivity with no compromise on your their product quality. Okay, so especially while processing difficult to machine materials. Okay, I'm talking about the material which is difficult to machine. So if you want to go to machining of this difficult to machine materials, that time industry want high production rate. Okay, and while increasing the production rate, there should not be any compromise about the quality and that productivity of your component. So they always demand that the cost of production should be low, okay, as possible as. Okay, they want to reduce the production cost so that they can have higher production, and they should get the higher profit. Okay, so that for that also we can go for to increase the product high production rate, we can go for this advanced machining processes. Okay, another you could take that our precision and ultra precision machining or nano level machining. Okay, so these are the requirements of today's our I can call sophisticated high tech industries. So your precision, ultra precision machining or nano level machining. So these are the requirement of today's sophisticated high tech industries. Okay, which one cannot fulfill with the help of our conventional machining process or no, our traditional machining process. So you have to go with the advanced machining process, or we have to go for our advanced machining processes. Okay, so this is the answer of our why do we need the advanced masterpiece. Now let us consider. Now up till now I was telling about the some situation. Let us go with some practical example. Now see here. Okay. Here I have shown some examples. Okay, you can see on the screen. Just observe that each and every component. Start from figure 1, 2, 3, 4, 5. Now, now in these examples, okay, nano level surface finish, or I can call tolerance, okay, that is less than the 10 micron, okay, that is a requirement of they want nano level surface finish as well as the tolerance less than the 10 micron, which is or which that cannot be achieved with your conventional machining process. Okay, so which remove the material in the form of chips. Okay, if you use conventional machining, definitely we are remove the material in the form of chips. Okay, where the size of your chip itself is a few hundred of microns or more. Okay, but here we want nano level your surface finish as well as the less than 10 micron tolerance. Okay, so you need the process where you are remove the metal in the form atoms or the molecules. Okay, and that removal of the metal in the form of atoms of remove can be achieved only through the your advanced machining processes, as uh, I mentioned in the my previous slide also. So for solution of these all problems is the advanced machining process. Okay, now see, now see at this slide. So top left hand corner, top left. So there are two parallel here. There are two parallel holes are there. Okay, here that parallel holes with your wall. Okay, in between these two. So to drill this hole perpendicular to this wall, okay, to drill this hole to perpendicular to this wall is very difficult because the hole's diameter is maybe around 1 mm, and your hole length say around 100 mm. So the question arises is that which conventional machining method can do this? Okay, which conventional machining can do this? So, to the best of my, I can say, to the best of my understanding, there is no conventional machining method which can drill the hole like this in such component. So only I can say only electrochemical machining, okay, which is advanced machining or non-conventional machining process, can serve your or can fulfill to your requirement. Okay, so we will discuss about the electrochemical machining also. Okay, so using the electrochemical machining, it is very easy to drill these two parallel holes having the diameter 1 micron and length is at maybe near about the 100 mm. Okay, so such another example also here I have shown your turbine blade with a cooling holes are there here second. So for this purpose also we can go for electrochemical machining. Then here I have given the that controlled hole drilled in a inconel metal using again ECM. Then here you can take precise wire cutting. Okay, I have one video about this internal gearing and this external. Okay, here I have shown that male and female. So this component can be produced using the precise wire idiom, okay, wire cut idiom. Then here you can see uh, taper 3D cutting. Okay, so you can obtain this shape using the wire cutting also. Then here also we have some parts, okay, patterns of where holes are drilled by the your electron beam machining. You can see some examples. Actually, these are the images or these are the outcomes of the EBM which we got from the different research papers, and that these all are mentioned in the that advanced machining process by VKG. You know? There you will get the reference from where they have taken. Okay, from the research paper they have taken. Uh, Here Now we got the answer about the why do we need. Now apart from that, here I have mentioned some important characteristics of our advanced machining processes and its machine tools. Okay, just I will take characteristics. That first is the performance of advanced machine processes is independent of your strength barrier. That means there is no problem about the hardness. Then performance depends on the thermal, electrical, magnetic, or and your chemical properties of your workpiece material. Okay, so depending on the properties, you can use the different machining processes. Okay, that we are going to see in the further chapter. Okay, then we can use this advanced machining processes for different kind of energy in direct form. Okay, for this advanced machining processes, we are using different kinds of energy. Then in general, low material, low mode rate, that is MRR, we are getting for the all machining processes. But quality product we are getting. And last characteristic is that comparatively high initial investment cost is there of your machine tools and high operating cost also. Okay. So these are some characteristics of your advanced machining process. Okay. So here I have given the reference also, advanced machining process by VKG. Whatever I am telling, no, there I have some reference. Okay. No, here I am not telling my philosophy. I am giving some reference. So if you see the vacation book, you will get the. So this is about the our today's lecture.